I'm Thomas Penn. I'm working in eBay in search backend. I have been with the company for more than 7 years now. And I'm organizer of the meetup. And in case, so we're still finding all the speakers. In case you know someone you want to recommend or you want to volunteer to speak, just let me know. So we will see how things can pan out down the road. Before we start the meetup, normally we welcome anybody in the audience to make any announcement. Anyone? Raise your hand. Okay.
My name is Stefan Gower. I have a website up for topicscout.com. Got some cards here. It's very unusual. It is a classification site that is working with large topic trees of over 10,000 topics. It's actually classifying these up to precision levels are 80%, over 100,000 web pages. And all the topics are generated automatically, no human editing, and the cost of creating a topic is almost trivial. So take a look at the data's there on the website. There's some pretty interesting lexicons there. And there's thousands of examples.
Thank you. Any more announcement?
Thomas, you have to turn the music down. I don't know where it's coming from.
I don't know either. Okay, let's finish that and then I work on the music part. Any more announcement other than the music part? All right, so let me quickly introduce tonight's speaker. We actually call the person, the name is a little bit long, but we call him JD, who is a research manager in Geo team in eBay. And tonight's topic is about machine translation. Okay, without further ado, I just hand over to JD. Thank you. I will work on music.
Start with music. All right, so as Thomas said, I'm going to present what we are doing at eBay in their area of machine translation for enabling cross-border trading. All right, and there'll be mainly three parts to my talk. One is motivating why eBay went into machine translation about a year and a half ago, and what specific or what difficult about what specific about machine translation at eBay. And then I'll talk a little bit about the team time permits. All right, so motivation. As you know, the world is not optimized for cross-border trading, as not everybody speaks the same language. And as you can see, a lot of Russian, a lot of Spanish, Chinese, and of course English is spoken around the world. And if you join this data with the expectation in terms of e-commerce growth, you clearly see that there's a huge opportunity in terms of commerce in Spanish-speaking countries and Russian-speaking countries. And that's mainly the motivation why we went into machine translation, is really to accelerate cross-border trading and allows people from around the world to connect with buyers and sellers on eBay from anywhere and buy their goods and trade. And actually, so as I said, maybe I should move that away. We started machine translation about a year and a half ago, and we launched machine translation in Russian, Latin America, meaning covering Brazilian and Spanish, and more recently in Europe to facilitate intra-Europe cross-border trading. And of course, we're going to tackle more languages in the coming months. All right, so let's look into how we do machine translation at eBay. But let's start by what we translate. So on eBay, on the eBay website, we have two types of contents. We have static pages, meaning menus, navigation bars, and specific content, which is fairly static, meaning it doesn't change every day. We have experts writing this content, maintaining it, And there we can use translation expert, linguists to translate it there. Right? But we also have dynamic content, meaning all the goods that people are listing and selling every year on eBay. So we have about 30 million items listed every day on eBay. I think we have close to 800 million items available to a US buyer at any point in time, so that's a lot of content. And actually, if we want to translate that content, we need to resort to automatic techniques. So let's do the math and see what that would take to humans to translate that. So, for instance, last year we had about 60 million US items eligible for cross-border trading into Russia for commerce in Russia. And let's assume that a listing, meaning the title of the good that the seller is listing, along with a description, which is usually at eBay some natural language, free-form text, is about 3,000 characters, and that we have a sentence duplication about 50, meaning half of the sentences don't need to be translated because they are redundant. And let's assume we have a huge army of 1,000 translators. So to translate that much inventory, it will take 5 years. So clearly, it's not scalable, right? We cannot translate the eBay inventory manually using language expert. And that's why we need to resort to machine translation automatic techniques. So what's the translation flow? How do we use machine translation? So let's say I'm a French buyer sitting in France. In France, I want to buy sunglasses. So the first thing I do is I issue my query in French here, Lunettes de Soleil Homme, which is men's sunglasses. And I press search, right, which is recherche in French. And what we do, if we want to enable, or if we want to expose to the sellers the US inventory, meaning the sunglasses that are listed by US sellers on the US side, we first need to translate that query, right? So, Lunettes de Soleil Homme here will be translated to men's sunglasses. So that's the first call to the machine translation service. Then we need to run a query against the US search engine, right? In other words, we need to retrieve all the US sunglasses in order to be able to show them to the user in France. But these, of course, sunglasses are in English, so we need to translate them. So we need to call the machine translation engine again and take all the sunglasses here, which are in English, title and the description. Here we're showing only the title of the goods. Would you translate the data into French? And then when it's translated, we need to show it to the user. But the point here is that the user experience for this French buyer should be as good as it is for a US buyer issuing a query against the US search engine in the US, right? It should be super fast. It should be so the user should not have to wait to translate. So one of the challenges is that translations should be extremely fast. So how do we do that? So we resort on statistical machine translation, which has started kind of about 20 years ago, but is considered now almost competitive with human translation. And the idea behind machine translation or statistical machine translation is to train the computer to be able to translate from one language to another. And we do that by just feeding the system with a large amount of translated data, let it learn the statistical regularity between the two sets of documents in fair translation, right? And that's called building a model. And then when we have a model, translation is just about sending a source sentence to this model, checking the statistics, and trying to find the most likely translation for the given sentence. By the way, if you have any question, feel free to interrupt. Yes, please.
Is there a number of n-grams you're using? I'm thinking of languages where you have adjective first versus adjective last. You could get some long strings, and if you don't have enough n-grams, you'll never match.
Well, so in machine translation, we're talking about the length of the phrase. And your question is, do we limit the length of the phrase? Yes, for efficiency reason. But we found that in the case of eBay title, a fairly limited, like 5 to 6 words in the phrase, cover most of the need in terms of translation of titles. This is our titles, again, are short sentences that the user are putting as titles of the item to describe what they say. When we go to translation, it's a little more complex and we need to resort to longer phrases. So we're considering those. Okay, so I said we feed the engine with training data. So what do we mean by training data? These are what we call machine translation parallel data, right? Which are documents with their translation. And this data is produced by human translators, so that the translation is of high quality. So here's an example. It's hiking guide, I think, in German, with its translation in French. And that's typically the kind of data we feed to the machine translation engine. We're actually using two kinds of data. We're using public data that are available on the web. There are a lot of resources, and they're not for e-commerce. So you can find easily European Parliament translated data. You can find medical documents. You can find technical documentations that are translated. But you find little e-commerce specific data, meaning translation of products and description of products and product features and things like that. We also feed the system with monolingual documents, meaning documents in the target language. So here, for translating from German, or trying to train an engine to translate from German to French, we would also feed the system with a large amount of French documents. And the reason is that we want to teach a system to be fluent. And basically, what that means for the model is to be able to measure how likely a given sentence is in the target language. For instance, in English, bag red is much less likely than red bag, right? Because adjectives usually go before the noun. And that's a kind of knowledge you can acquire from monolingual. So we feed monolingual data to be able to teach the system fluency. So what is the translation model for a statistical machine translation engine? It's two things. It's a phrase table, and phrase table is simply put phrase pairs or sentence pairs. One is the source language, the other one is the target language. So here, this is a phrase table for Portuguese to English. And so for the first example, we have the Portuguese phrase 2 or 3 phrases. I don't speak Portuguese, so I don't say it right, but and then its translation 2 or 3 sentences. And then the numbers behind that are probabilities and statistics used when we're making translation decisions. And also, as I said, we also the model is also contains also a model for fluency, which is basically all the sentences observed in the monolingual training data with their likelihood. So I think here it's log negative probabilities, but basically it's the likelihood of each of the sentence. So this was one of the earlier model we trained, and this one was trained on 8.6 million sentence pairs, containing roughly 93 million words. And the fluency model was trained of 150 million sentences containing about 1 billion words. And
Question?
sure.
So do you just look at translations which are just pairwise the same, or do you generalize patterns that you see that repeat in the sentences?
That's a purpose of statistical machine translation. So the with the amount of data, the system is trying to learn statistical correlation between sentences and sub-sentences that we call phrases. So hopefully the system is learning patterns, yes. Actually, that's okay. Okay, so and on this data, the phrase table has 30 million phrase pairs, and the fluency model about 500 million phrases. Okay, so I said, so we're feeding the system with what we call parallel data, right? Documents and their translation in the target language. But I didn't say we tell the system at any point what word is translated into what word in the target language, right? So we don't provide the system with what we call alignment. So we just feed the system with sentences. The system has to discover what word corresponds to what word in the translation. And if you look at example of sentences, sometimes it's very tricky. So let's say the debate is closed. Example in the alignment with the French sentence, the debate loop, fairly straightforward. Each word in the French sentence aligns with only one word in the target language. But then if you take another example and you accept that principle, things are getting a little more complex because there's reordering, right? The verb and the pronoun are not in the same order in French and English. And if you take even more complex sentence, then it becomes very messy, right? The alignment is all over the place, there's a lot of reordering happening. And there are even some words that are not aligned. In the French did, the article, doesn't have any equivalent in English in that sentence. So it's a fairly tricky problem. So how do we solve that? Well, that's using unsupervised word alignment based on the EM algorithm. It's a fairly standard algorithm that was proposed by IBM 15 years ago. And the idea is actually fairly simple, fairly intuitive. So the goal is to learn translation probabilities, right? We want to know what phrase, what word translates to what word. If we add the alignment, if we knew for every sentence pair in the training data what word was translating into what, computing this phrase table would be easy. We would just have to count how many times this word is aligned with that one, and it would give us a probability of this word being translated into that other word. But conversely, if we had the translation probability, we could also compute the alignment, right? We put the most likely, we'll align each word with its most likely translation. And that's exactly what the algorithm is doing. Starting with a random alignment, computing the translation probabilities, and then reiterating that process. And it actually does converge to the right alignment. So I won't go into the mathematical detail, but the idea is as I just described, iterative process. Yes?
You had, well, basically you're talking about doing word alignment, but on the example you had on the slide before, I assume since it was would, you were doing a subjunctive question. Would you do, was that represented by the French ending? And in which case there are auxiliary words that come and go between languages?
So, so there are models. So we're using models of
Modal is what I was saying
language
rather than model.
to decompose the language. So yes, you can perform the alignment on suffixes and prefixes. We don't do that for English, but for other languages, in particular German, which are a agglutinative language, where there's a lot of compound that you need to split, that's necessary. Right?
So you can add and subtract words as needed.
Yes.
You go between languages.
Yes. So in the case of English and French, actually, it's not really necessary. You don't need to split the words, or you don't need to understand the suffixes and affixes of words. Or maybe I misunderstood the question actually. Maybe you're asking whether or not we ignore some word when we're aligning the
Well, you're talking about word alignment here, but things like modals, would, do, those auxiliary words, you have to insert them in English, and you don't do them apparently in French, and that's just the tip of the iceberg potentially.
Yes, as I said in the last example, not every word needs to be aligned. So the model is able to skip words and ignore some in any language, in the target language and the source language. Sorry, I thought you were talking about suffixes and conjugate. All right, so as I said, the model consists of a phrase table and a fluency table. So how do we use it? Well, a translation tab. Well, let's assume we have a Portuguese sentence we want to translate. In that case, frases de música de los hermanos. What we need to do is to look into the phrase table for every word, background, trigram, almost all the sentences, all the phrases that we can generate from that sentence, and find which phrase translates into which and compute the most likely sentence. So what needs to be done is actually serve the space of false translation given the frame, the translation priorities we have in the phrase table. So here is what we call the prune tree of the search space. So actually the real search space is much larger than that. Even for a sentence like that, it's about 20,000 hypotheses. But you can do fairly standard pruning by limiting the skipping of words, for instance. You may say, okay, I don't want to skip more than 3 words in my hypothesis, right? So by doing this kind of heuristic pruning, we can reduce the search space and the number of hypotheses to consider into a few seconds. But still, at translation time, you have to compute the priority of all these hypotheses in order to find the most likely translation for the sentence. But we can do that fairly efficiently, as I'll show later in the presentation. So actually, I'm not going to give any more detail of machine translation itself, and I'm going to switch focus now on why it's difficult at eBay and what's specific about translating the eBay inventory. As I said, if you want to know more, there's ample of literature around machine translation, and you can learn much more than what I just described.
Can I ask a question?
Sure.
Before you move into why it's difficult for eBay, so how do you measure the quality of these?
I'll talk about that.
Okay, you're coming to that.
Yes.
Okay, cool.
Regarding the way that you want to manage chapters. I'm not expert in NLP, but I remember when I have used some library like example code. I know that there are the methods that create like parse a sentence and create a tree, right, from that. My understanding is that if we have trees, it gives us some pattern, right? And only translating from a general pattern is is easier. So my question is why you have chosen this mechanism rather than.
So there's been a lot of work around trying to use dependency parsing as a feature in machine translation, name entity recognition, and unfortunately, although you gain a little bit from that, it hasn't shown to be increasing dramatically the performances. What's more promising now is what they call using semantic with machine translation. So there's a lot of research into combining knowledge about the language and statistical approaches. So if you go back to the history of machine translation, until the 80s, it was mainly based on linguistic rules, manually crafted for the most part. And then with machine translation, people or the academia shift totally to purely statistical techniques without any language-specific domain. So now there's a tendency to group these two and try to get the benefits of both worlds. So using dependency parsing and this kind of this approach, but again, people are now looking into leveraging semantic parsing for machine translation. Okay, machine translation at eBay. So as I said in the beginning, right, when we have this French buyer issuing a query and potentially purchasing US inventory, we need to be very fast. And actually, our machine translation engine is very fast. So in terms of search, we have very, very strict SLA. So the response time of the engine must not exceed 20 milliseconds in terms of translation. So when someone issues a query, we must respond to that query within 20 minutes. We must translate that query within 20 milliseconds. The reason is that, remember, after we've done the translations, there's a lot of other things to do, right? We need to search, we need to call the US search engine, then we need to translate back the inventory and then show it to the user. And actually, 95% of our queries are served under 40 milliseconds, or around 40 milliseconds. So machine translation can be very fast, and it is at eBay. And this is achieved through optimizing the algorithm, but also leveraging servers and an efficient infrastructure to support machine translation. Another aspect of eBay which is important to take into account is the scale of things. Right? As I said, we have at any point in time almost 1 billion items available for purchase on the US website. And that means that, for instance, we're selling a pair of shoes every 2 seconds, women accessory every 2 seconds, headphone every 12 seconds. We sell a car every 2 minutes on eBay, even a boat every 35 minutes. So not only we have a large inventory, but also we have a lot of queries coming. So that's another reason that we have to be extremely fast in terms of in-depth machine translation. And also the diversity. So think about a traditional translation agency, right? They would get a project, for instance, maybe in the medical domain, and they would spend effort to translating that. So that is their focus on one domain. At eBay, the story is much more complex because we have all sorts of items, right? We're selling consumer electronics, power tools, sporting goods, even pets or clothes for pets, perfume, and sometimes we sell $1 million diamonds, right? So in that case, we have to make sure that the translation will be quality. So this is another challenge of the translation task, is that we have a lot of diversity, and then we need to reflect that diversity in our training in order to be efficient at machine translation. We have around 15,000 leaf categories or different categories on the eBay website. So again, lots of diversity.
You didn't decide to solve this issue by just scaling up, say, doing 20 languages and translating everything into 20 languages offline. So then you would already have them translated.
Well, we cannot translate query offline. We don't know what our user.
Well, the query is in the native language, but all the descriptions being
yes,
could be done beforehand.
So actually, we do cache translation. So so offline, well, we have again like 30 million items listed every day. So still, we need to translate this 30 million items, or at least the ones that are requested by the user, right? So when a user issue a query and we serve some item, we translate these items, also cache a translation, so we don't redo it again and again. So
you wait until a query comes in before, as
yes,
opposed
and then
to
we cache it.
You get a description, you translate it into all the languages, and then whatever language a query comes in, it just goes against what's already translated. Then you have no speed problem.
Still for the queries, and also again 30 million items to translate every day, right? Within 24 hours. So it's not so much as
you just
as
have
a
a
search
way,
constraint.
but your machines can take, if they need
Yes.
10 minutes to
You
do
can
it,
scale.
they can do it, just buy more machines.
Yes, there's a trade-off between cost and efficiency, but yes. In terms of search, also, yes, please.
I'm just curious that in which case you need to translate the query. For example, if I type a query in Chinese, most likely I'm interested in like product from China or product in Chinese. So in that case, most likely we don't need the translation, right?
So when you issue query in Chinese, we need to translate it because we
In
want.
Chinese product, most likely I'm interested in Chinese product
No.
rather than in product like which is like American product, which can be like a match after translation. That's probably not what I'm looking for, right?
Not necessarily. I mean, remember, our goal is cross-border trading. We want to show to Chinese buyers goods that are sold in the US and that maybe they don't have access to in China. So in that case, we may want to translate the query so that we show US invention.
My argument is if a person is searching in a native language, most likely interested in the product from their native country or something like that.
So users have the possibility to explicitly say what they want to see. So they can click or check a box on the website and say, I want to see only local Chinese inventory, or I want to see US inventory, or I want to see worldwide inventory. So that's our purchase. And actually we have observed that when people don't have necessarily the knowledge that we're showing US inventory, they just want to buy something. I'm a Chinese seller, I want to buy something on eBay. I don't care if it's coming from, I don't even know that we're showing US good. So I I issue my query in Chinese, and then just it's transparent for me. I don't know.
So you translate everything into Chinese, like for example, if I have a file in Chinese, there's a product which is completely in English. You translate everything into Chinese, including the product description and the product title, everything.
So actually, I'm going to touch a little bit about that.
People do it. I mean, the reason this project was done is a lot of Russians come to the eBay.com site and shop and buy things. Not kitchen tables, but one Rolex.
Yes, so that's right, it's a very good point. So cross-border training started even before we enabled machine translation. Right? So even before we had machine translation, we would see Russian queries coming to the US in the future. But they would return no results because the inventory was in the US, right? Was in English. So and that shows that yes, there's a need for translating the foreign queries into US.
So we have some listings which are in foreign language, which is why some of the queries are sent in both languages, but the majority of the cases are not in the foreign language. They need to be translated that way so that they are accessible.
A lot of companies don't do cross-border trade, but eBay does a significant business with cross-border trade. I just bought ski boots from Canada, which didn't need to be translated.
So actually, as I said, we are saying foreign queries, meaning when we from the queries from Russia, we see a lot of Russian queries, but we also see English, and sometimes it's difficult because we should not try to translate queries in English, right? So we need to be able to identify the language. So for Russian, that's very easy because it's Syriac, it's a different alphabet. But think about people issuing queries from Portugal, right? Or for Brazil. So if they type TEAM, they may mean something in Portuguese which is not the word team in English. Or something from France. Someone types figure. So figure in French means face, it's not a number. So we need to understand when to translate and when not to translate. Sometimes that's tricky. And we also see a lot of queries. For instance, here we took a sample of 10 million queries, and we identify like about 300 likely misspelling of the word something. So not only we need to be able to translate all sorts of queries in all sorts of languages, but also we need to understand that sometimes there is misspelling in the original language, in English, so it's a very wide range of input. But even more than that, there are keyboard layout issues. So in some languages, Syriac, Korean, Arabic, so they use a different layout, a different keyboard. But still people sometimes want to type English, so that they need to switch from one language to another, from one keyboard layout to another. And what we observe is that quite often people forget what layout they are in. So their keyboard is in the Syriac alphabet, but they think it's in English, and they start typing an English word with the Syriac keyboard. And that results, for instance, in them we have a Russian word, or Russian-looking word, which is not actually a valid word, but it's a keyword iPad typed with a Russian layer. So in that case, we need to identify that well, there may be a keyboard mapping issue, and we need to decode the characters to English to recover the word, translate it, and then start to write the nature. But again, there are ambiguous cases. For instance, this Russian word here looks like a V and A. It's a valid brand, I believe, in Russia, but if you decode it using the keyboard layout, it's also a valid acronym in consumer electronics. It's DFP, meaning digital flat panel. So again, a lot of ambiguity that we need to take care of. Even worse, so what we have observed to our surprise is that sometimes people switch keyboard in the middle of the word. So they are, for instance, using the Syriac alphabet, in the Syriac layout, they start to use the Cyrillic letters that look like English letters to type case in that case. So the Syriac C, like there's a letter in Syriac that looks like a C, so they use that to start typing. case, same thing for A, and then they're about to type the S, they realize that it's the wrong layout, so they switch the layout. And they switch to English and finish case by typing S. But actually for the computer, it's a strange entity that is coming, because it's half Cyrillic with a specific UTF encoding and half English. So again, we need to take care of that case and decode the word while you are translating. Actually, we had a paper at EMNRG last year, so if you're interested to learn how we do that, you can find it. Another issue that we have is that we should not translate everything, right? If someone is typing apple, we should probably not translate it to the fruit meaning of the word, because we don't want our iPhone inventory looks like grocery shopping in Russia. Same thing for like clothing brands. There's a lot of clothing brands that contain valid English word, and if you don't pay attention to that, you will translate. So Hugo Boss, we should not translate into the boss, right? Hugo. Clothing like Gap is another example. Coach, Free People. There's a lot of clothing brands that are actually English words that we have to not translate. And it's not specific to English, of course, any language. Petit Bateau is a French brand, which, if you translate literally, means a small boat. But we should not translate that. We should understand that when the user types Apple or Hugo Boss or Petit Bateau, it really means the brand. All right, translation quality. So back to your question. So we have several ways to measure translation quality. We have automatic techniques or automatic metrics that we use before we launch on the site the translation for the machine translation model, and that we use to tune and measure the performance of a model. And these are fairly standard techniques. We may have heard about the blue score, which is basically using human translated sentence as gold standard to compare or to measure the quality of a translation produced by the engine. And basically it's looking at the kind of overlap in terms of n-grams in the translation and the gold standard. But you also have other techniques like word independent error, position independent error rate, based on any distance that allows or not to movement of block of words with just single words. Yeah, so there's a few techniques we use for measuring the quality and actually optimizing our models. But we also use human judgment because the blue score is not always very accurate, and other metrics are not always very accurate. So anytime we launch a model, we have a fairly constrained QA process where we ask linguists to actually rate the quality of our translation. And we use we have several ways to do that. For queries, we actually run the translation against the search engine, and we ask the linguist to determine or to assess if the search results are actually meaningful for the query. And we also, of course, ask the linguist to rate the quality of the translation itself in terms of fluency, adequacy, and correctness in the target language. And then, of course, we have A/B testing, fairly standard in the industry, right? Once we are at the point where we can launch a model because it passed the automatic and human language evaluation, then we enable it to on our website, but restrict it to a fraction of our users, and measure the impact of the translation using several behavioral metrics. But we're not done. Even if something passed an A/B test, we still do a lot of analytics to constantly monitor how we're doing in terms of translation. We look at basically using activity log, looking at how our users interact with the site to assess the quality of our translations. Yes.
So I have a silly example. I'm sure your translation did not do this, but just for the sake of example, say if someone was purchasing something like a yellow dress, and they had an image of a yellow dress, and it's translated over, instead it's in French, instead of being shown, it's, you know, they put it noir, and obviously it shouldn't be noir. Is there any way for a user to react in some way that you can infer that there was an incorrect translation and get feedback from it?
Well, there's two answers to the question. First, there are implicit metrics, so we can look at how the user behaves, right? If some people never click on our translation or never buy the good, that's maybe an indication that we didn't get it right. But also there's explicit feedback, so people can leave comment and give feedback, explicit feedback about your translation, and that's another way we can get information about the quality of our translation. Yeah, so we're looking at, once we have enabled translation analytics, like the query volume, like do we see an increase in the number of queries, do we see a drop, number of unique visitors, engagement, like how long people stay on the site, number of null results for our queries. So usually, anytime we launch translation, we should see a huge dip in the number of queries returning null results, right? Because all the queries that are in the foreign language that we did not answer properly before we know translation are now treated correctly and we return results. So we should see a drop in number of null results, queries not returning anything. So that's some of the metrics we're using. Yes. As I said, people can leave explicit feedback, and so this is the feedback we got from Mexican users about our Spanish translation and for Russian users. So and it's actually very encouraging and usually valuable. So people are very enthusiastic about machine translation for e-commerce. So here's the code. Everything is in Spanish, very important for that user. And people can buy even if they don't understand English. We found that 68% of our Russian users said that translation improves their shopping experience. 80% found the translation of the quality to be very good. Like here under the code, much clearer way to understand what exactly is sold. I like this one. Any machine translation better than confusion. And everything got clear now. We also conducted a survey to explicitly ask people if they feel that machine translation is of quality and helping their shopping experience. Actually, even for even for highly fluent people or people that rated themselves as highly fluent in English, even in that category, we had more than 30% of the users saying that translation improves their selling experience, and quite a lot of people say actually that the translation is of the highest quality out of a scale of bad quality, medium quality, good quality, and highest quality. So it's very encouraging.
There's a money-back guarantee with eBay. Do you ever get that exercise because the thing was translated wrong?
So I think we have a disclaimer saying so we show the translation, but user can mouse over the translation and sees the original.
They have no knowledge of the language. They're relying on eBay to do a correct translation, and if you don't,
yeah. So there's a disclaimer on eBay saying that machine translation is not perfect, and we may get it wrong in some cases. And in that case, I mean, machine translation is to help the impressions, but there's no, we cannot guarantee it's always going to be perfect. So
you cannot guarantee it.
we can.
Well,
Yeah, I mean, machine translation is very hard, and
Yeah,
even
well, the user walking up to eBay doesn't know that this is machine translation. They know it's translated, and eBay is putting its reputation behind the translation that it's correct. If you get it wrong and you sell the black dress for the yellow dress, they're gonna want their money back.
yeah, that's right, that's right. But so legally we're not liable for the quality of translation. Again, machine translation is a very hard exercise, right? And I mean, even try Bing and Google, you see that they don't do always do a great job at translation. So it's a very hard problem. So we cannot take the risk of like claiming that translation is always going to be perfect, right? So we're providing that as a service to help the user.
So people can't exercise that option to say the translation was wrong.
They can give feedback, and we're going to improve. Actually, we're constantly using that feedback to improve our engine. So hopefully, we're going to
Continuing the yellow and black dress example. So if I bought the dress and, and thought it's the wrong color for the translation, would I be able to return it anyway, or is it just
Of course.
fait accompli, I have to keep the dress as is now?
No. So that's a different. No, most of the users allow returns. So in most cases, you can return the item. Yes. Also, remember that there's an image with the items. So
Yeah.
it's not only the translation. So you have all the data to ensure that.
It's a little bad example because of the color, but then the other example probably with image wouldn't help you so much.
Like the cover of a couch or the couch itself. So if you just want to buy a couch, you by mistake bought a cover of the couch, just the couch cover.
Yeah, that can happen. And yes, we're aware of that, and we're trying to do our best to make sure that this kind of bad experience don't occur.
Could you return the item under all circumstances, or does it cross a certain price threshold, or are you then stuck with the item?
So it really depends on what the seller offers. So again, we're just a marketplace, so we don't own the goods. So it's really the seller policy. So we're giving a lot of incentive for sellers to offer the best return policy, but we are at the end one of the one decide.
Understood. And it is a very hard problem.
Yes, but we try to make sure that this is very explicit. So if you go to the eBay page, you see clearly whether or not the user accepts returns. So when you buy something, you should know whether or not you're going to be able to return.
So does that mean that all the production translation on eBay is done by machine and no human intervention?
Yes, for the dynamic context, in all the items, yes, it's done by machine.
And do we have any statistics on how often that those type of return or any negative feedback comes in with the machine translation?
We do, but we're much more interested in the positive feedback, which I just showed, which is like much more frequent than the negative feedback. So yes, of course, we have the statistics. Yes.
So for these cases, basically translation motivated issues, the statistics do not differ much from within basically the country. So translation motivated issues are not they are not changing the statistics very much. They're not changing the statistics. So that means the customer using machine translation and the customer not using machine translation has the same feedback basically to the
Does that hurt? Okay, thanks.
Sometimes they might be blaming the seller instead of blaming the
Oh, no, so we want to know the error rates there.
All right, so
Could you share the samples of the people that were just
interviewed in
the people that responded positively? Was there a sample size?
I don't have that on top of my mind. Do you remember?
I think for that example, it's a little bit more than 1,000 people for that sample.
Okay, so I'm going to conclude with a quick word about the machine translation team. So it's a team composed of researchers. We also have, of course, engineers that are building all the infrastructure to make sure that we can serve translation very efficiently and very fast, as I said. And we also have, and it's very important, language specialists or linguists that are helping with producing training data. So as I said, we are using data that is available on the internet, also producing our own training data, and linguists are helping with that. And also, as I said, helping with ensuring high quality in the current and helping in the current process. One very important thing I didn't say is that our machine translation engine is built of an open source library which is called Moses here, and so we also contributing with improvement to that library which is open source by contributing back to the community. Yeah, so as I said, open source is very important for us. We're using Moses, and we want to make sure that all our learnings and findings are benefiting also the community. We also try to keep a tight connection with the academia and constantly engaging with researchers and to make sure we stay on the state of the art with machine translation. All right, that's it. Thanks for your. Any other question?
I have a question about the search. So you said the search process is that when the query is issued, you first go through translation. Does that go through every single query that comes in, or does it only apply to, say, different entry sites if it's coming from eBay in Russia, for example?
So we enable translation per geographic location. Right?
Oh, okay.
For instance, for Russia, so we would enable query translation for any query coming from Russia. But again, we have process to identify whether or not we should translate something. Like if it's in English, or if it's a query that could be valid in any language, and something like that.
And also, if the query is issued in so some of the listings may be in the original, like in language that's other than English, say for example Russian. And then when the query comes in, then you do a translation, search in the English listings. But then what do you do with the Russian listings?
We still show them.
But you still show them, so it's kind of search. So you issue the query using original language as well as the translated language and combine the results.
Because as we pointed out, we have some actually Russian items or Russian listing on the US website.
Can you do a Russian demo for us live?
I could if I had prepared for that, but I didn't. Sorry. Also, in the case of, for instance, Europe, so Russia, we started in Russia, there was no local inventory, meaning we didn't have any Russian seller listing goods from Russia. So all we could do initially was to show the US inventory to Russia. But if you think about France and England, for instance, we have inventory in both, right? So when someone issues a query in French, we get both inventory and then blend it in the search result and show both. And actually, users are not necessarily aware where at first sight where the inventory is going. If they click on the item, then they can see it's located in France, it's located in the UK.
Do you give different weights to the matches in different languages?
Yes. Yes. So the ranking process incorporates translation statistics and confidence in order to rank goods.
Thank you.
Like, I'm just curious, do you always need to plan the result? Because sometimes, for example, for acquiring foreign languages, the recall from the listing in the original language might be big enough, so there may be no need to plan, right? So to argue that the quality of the listing in the original language should be higher. The machine translation is not always.
Yes, so we did a lot of user testing, and we have a very country-specific way to handle the blend. for instance, in France, we may want to show more French items and limit English items to things that are not, supplied in France. In other countries, we may want to blend equally both kinds of supply. It really depends on the country, but yes, we are looking carefully into that and to make sure that we serve the translated inventory in the best way for our users.
So would it make sense to translate it back to the original language and show it to the user and see if the user agrees that this is close enough to what they meant?
I mean, for everything, the translation.
So English to French, and French back to English, and they're not going to be the same, but the user can decide if these are drastically different or...
So conceptually, yeah, that would be very useful to have some kind of user feedback about the translation quality. But the problem when you do translation and back, that you lose quality. So your initial translation may be good, but then translating back, you're incorporating another level of noise.
True, but if blue becomes red, that's a huge thing, and the user may decide that this is not what I meant.
Yes, that'd be very useful. The thing is that we don't want to involve too much our users at the cost of the user experience and the purchase process. The goal for them is to purchase, not to rate translation. So we have to be mindful about what we do. But maybe a particular idea is an opt-in, program where people could willingly contribute to helping us improve the translation rate.
So there may be certain relatively obscure kinds of items which may or may not translate into other languages in direct fashion. I have a specific example. Maybe it does translate their language, but there's a kind of woman's hat called a bird cage hat. And it's sort of a veiled kind of thing. It used to be popular in the 40s, but it's a real category, right? Under vintage hats or shows up. And I was trying to use that as an example, because when you get something like that, it's obscure enough even in English. I wonder even if it can be translated in any direct fashion into another language, and then of course the amount of translation text might be small or non-existent. So do things, because it's a very hard problem we're dealing with, do things sometimes fall off at the edges when it just gets too hard?
Maybe. And I'm not even sure what would be the right behavior in that case, right? Should we still translate literally and let the user try to figure out? I don't know. That's a good question.
How does the translation quality differ from more similar languages, like Latin languages versus like Eastern languages like Chinese and English? Is it better or worse in the language similar?
So yeah, there are differences between languages, and some languages are harder to translate. Now, on top of my mind, I don't have an accurate recollection of what is easier. Do you remember? Or do you have
we can say that some languages are more difficult than others. We know that, for example, Russian is more complicated to translate into English than French is. Depending on the language, the data which you can gather to learn from, even a harder language might end up not being as difficult. I mean, like if you compare Italian to Spanish, might be the quality of machine translation might be just as good as Spanish to English, because Spanish to English is, we have much more data which we can learn from. So let's say we have 100 times more data to learn from for Spanish to English. Even though Italian and Spanish are much more similar, the quality of machine translation which we end up with is close. I mean, it's not much better, so to say. So there's more factors to it than just the closeness of the languages. There are more parameters. If we have a browser, I have a Russian username, so I can basically present that live.
You want to try that?
Translate to Italian and Spanish, would you then necessarily potentially go from Italian to English, then English to Spanish?
So this is, some of the machine translation companies do that way.
we decided we will go and do the actual translation from Italian to Spanish if you want to have basically Italian inventory visible in Spain. The reason for that is we assume that there is some accuracy which gets lost if you do the translation over English. And I can give you a very clear example. If you take Russian and German and you want to translate from German into Russian, there's certain features in these two languages which would get lost if we would translate through English. Why don't you continue answering?
One question I have. Query and the listing through the same engine. Excuse me? Is the query translator and the listing translator going through the same pipeline? Is it the same engine?
It's different models because we don't train the engine the same way to train to translate queries and to translate longer titles or descriptions. But it's basically the same pipeline, just calling it a different model.
You might have a dedicated eBay Europe and eBay Asia separate sites, and then all merge it in when the query goes. Does it go across, or you have something like a common gateway where we can?
For the search engine?
Yeah.
Yes, it's a common gateway.
Okay.
I kind of missed the first part of your talk. I'm curious. Since other companies such as Google and Microsoft, they're also working on machine translation. So on a high level, what's the difference between your approach and their approach?
Well, we are translating specifically and training for e-commerce inventory. And actually, initially we tried publicly commercially available translation engine, and we found the quality to be not always sufficient for e-commerce inventory. And a simple example is brands. So there's many brands for which Google Translate is getting the translation. So it's tuning to, so we're tuning the engine to e-commerce inventory. I would say that's the main difference.
So that means that you are just like, you apply machine translation to a specific vertical, but under the underlying technology, what are the difference between your approach and, for example, Google's approach?
Well, I'm not, I don't think anybody is very knowledgeable about Google translation or in Google, so I'm not sure exactly what they're doing. But I suspect
sometimes they publish some very
yes.
sometimes high level technique in academia papers, but
what I can say is that it's similar techniques. It's also statistical machine translation. So the approaches are in a sense the same. And the difference is the training data and the way we tune the model and probably heuristics are using and we are using to make sure the translation is correct.
So this is the Russian site. That's what the Russian user sees if they go into ebay.com. I don't have a Russian keyboard. I couldn't type in any Russian query, but I will try to search for. So if I had typed it in Russian, it would give me the results back in Russian.
Okay.
And what JD was saying earlier is, I see the original if I hover over it, and I can give it a rating. I don't know what the rating is for this, but it looks.
Is that a real-time translation when you moved over that line, it translated, or is that already translated, just displayed now?
That is pre-translated.
Pre-translated.
And it's visible. So we do about 90 million queries, translate 90 million queries a day. We do pre-translation of about 120 million. And what is the rest to 270 million? The rest is so with some titles are being translated on demand as well. So we don't do pre-translate every title, but some. So we do about 270 million translations a day between queries and titles.
Yeah. What about the price? Do you apply the exchange rate on price too? The price. Did you apply that exchange rate on that?
Yes,
That's a
it
good
is.
one. I did not.
If you click on that, that is original
Yeah, right.
price. And you see here the ruble price. Yeah, that is obviously not machine translated. That is.
That's something to do is grab a couple of those Russian words and then paste them in the search.
Oh, that's a good. That's a good idea.
Not the whole thing.
You should remove that apple.
Is that a good choice?
No, the apple you should remove. Only the first.
Yes. Are we here on the on what network are we here? Okay. We can also do it the other way around, so we can just say, let's translate any English into Russian. Where is Russian? Do you see Russian? Okay. So give me a query.
Snow chain.
Huh?
Snow chain.
Snow chain. We don't have snow here.
That is in Russia.
Oh, what does it translate
It should
to?
be snow chains, plural in English.
Wow.
Is that it?
Yeah.
Well,
We have some good enough.
let's assume it is.
I'm Russian.
Oh, very good. We have somebody. We should have chosen some other language.
We can look at the pictures though.
Do we have a Russian?
Yeah, we do have.
No,
No, yeah, they are going to.
Something with chain.
Some change. Chair, I think.
So what was the difference here?
Maybe
What is this? Is that better?
Actually, the previous one was better.
Was,
This one
huh?
is worse, because basically what this one says is snow and then chain, two nouns, that's all.
In English, the starting, it shouldn't be snow chain. If
Ah.
you want tires, chains on a tire, chain has to have an S on it. So it's not correct in English. You need to add an S before you translate.
Wow.
If there's no open source technology, can these machine learning or these type of translation at this volume completely the traditional technology?
Sorry?
If there's no big data, because you listed a bunch of open source big data projects, if there's none of those technologies, but
Operator error.
Yeah.
Sorry. Yeah.
See, with a real Russian query,
Yeah.
you get something.
Yeah, that's wonderful. Very good.
So you can still see that.
I think that's probably because it's translated back to, like Russian, the snow, the two words snow and chain. So they get translated into English as snow chains, and then it's feeding to the search engine. Search actually keyword matches snow and chains, and then you get translated back.
That's good.
What's an idiom? And you're not necessarily gonna do well on an idiom.
Yeah. Idioms are a challenge. I mean,
What if you tried snow chain as one word?
that matched what we wanted, right? That matched what we wanted.
But that's not even clear what that should return in English.
Yeah.
Nothing. It doesn't translate. So let's. But I bet with you, if I put snow chain in here, it will give me a result. There's so many.
Yes, no
so
change
many.
will be, yeah,
So many items on eBay.
Yeah. This will get.
That's something I didn't
Oh,
mention.
there is something else. We do also some search optimization towards these kinds of issues.
Spelling
So
errors.
we might be splitting it at the end of the day.
Exactly.
I mean, Brian will be able to tell some of that.
Yeah, spelling errors or anything you might
There
do.
is some magic on that end, independent of the translation.
Yeah.
Yeah, still one point which is important to highlight is that the English we have to deal with is not always proper. and we see also of misspelling and grammatical error. Still, we should be able to return something.
Are you thinking about putting eBay public, making it public?
We don't know yet.
It might help people to help, if it's a translating service built for commerce, it might be more accurate than Google Translate. Maybe.
For the commerce purpose. Yeah, I mean, right now we are focusing on putting it in the workflows of eBay. What happens in the future, no one knows.
Okay.
So do you also have like English to Chinese translation?
I'm sorry?
Do you also have English to Chinese translation?
We're working on it.
So for the translation technology you develop, are you going to like open source some of the technology?
So Moses is open source. I mean, you can go into website online and download it. I mean, Moses itself is without the models. I mean, it doesn't have the models. So you have to have some scientists sit down, train the system, etc. That's what we started doing in 2013, mid of 2013. And initially, it's going to be challenging to build a robust system which can compete with the top MT systems out there. But if you focus on certain domain and have a lot of data, and we get a lot of data today, then yeah, I mean it's a good thing to do.
So do you plan to provide some kind of like translation API so that like people from other e-commerce world can collaborate?
That's basically a similar question to, yeah. I mean, we don't know. I mean, nothing is impossible, but right now we're focusing on our own workflows. So.
All right, thank you.
Okay, thank you.